Assalamu alaikum ji. Dear students, before midterm we have done so many things in the probability. We have seen the different kind of probability issues and distributions, and in the last we have done the hypothesis testing using Z distribution. In that continuation, now I am starting the new chapter, chapter number 18. Student T distribution. It is similar testing of hypothesis, but now not with the Z distribution but with the T distribution. And I have told in the class that where we will go for, or we will follow the T distribution, and this is very simple and explanation. I have told you that where the variance or standard deviation of the normal population is unknown, and distribution number of observation is less than 30, only in that case we will be following the T, otherwise we will be following the Z distribution. I'm repeating, the following the T distribution depends or based if the number of observations are less than 30, and along with this the sample population variance or standard deviation is not known. If the population variance or standard deviation is known, or n is found to be more than 30, then you will be following not the T distribution but the Z distribution. With this issue, I'll be explaining four kind of tests in the T distribution. As you can see there, the first test would be the testing hypothesis about the mean of the normal population when population variance or population standard deviation, because it is a sigma, it is not a square, it is a population standard deviation. Obviously, if standard deviation is known, it means that the population variance is unknown or also known. If the population standard deviation is not known and n or number of observation are less than 30, this would be our first case. First case of testing hypothesis about the mean. The second case would be testing hypothesis about the difference of the mean of the two normal population, but the two normal population would be having similar or same standard deviation or variance but they are not known, obviously. And the third case would be the same difference of the two means of the two normal distribution, but now the population variance they are not same. And the last test would be the testing hypothesis about the difference of the two mean with paired observation. Paired observation, in a special case, I'll be explaining this case when the time comes of this explanation. So right now I am starting with the first case, and one by one I'll be explaining all these tests and along with the formulas and the process. For the reference, I have taken your book exercise, and this is chapter number 18, the student T distribution and statistical inference, and all these kind of formulas and questions are there in the book. You can find it, and this is on the page number 239, and 239 onward you would be having all this exercise that is being given to you, and if it is not being given to you, then you can ask me. I'll be uploading on the LMS. Anyway, I would not be explaining this chapter in detail, but I'll be just practicing the question related, and those questions would be taken from the exercise, and exercises starts from the page number 265. And in exercises I would not be indulging ourselves into any kind of proofs and such kind of things, because we are just having a practice of hypothesis testing. So hypothesis testing is basically starting from we can say that from the question number 18.14. So from 18.14 I'll be practicing this question, and how can we test the hypothesis about the mean and the differences of mean. So I'm going again to my these examples. Guys, you know about the process of hypothesis. The six-step hypothesis I have explained in the classroom, and we know that we are having six steps. In the first step, we establish the statement of hypothesis, and normally, if there is a testing of one mean of the normal population of unknown sigma and less than n30. Null hypothesis would be that our population mean would be equal to some available mean. If the mean is given to you to be checked, so obviously I will be putting that value. Otherwise, the normal population mean is you know that it is equal to 0. So in normal case where the population mean is not given to us for what we are going to test for, so here we will put the value of 0, because the normal population having the mean of the normal population is always 0 if it is not given. In this is the mathematical expression of the hypothesis, null hypothesis. Otherwise you can write it in this description form, that is, the population mean is not statistically significant or not significant. Not significant, it normally we take there when we are not given the mean and we are taking the value of 0. Otherwise, this may not be equal to 0, obviously. This may not be equal to 0, that may be more than 0, or it may be less than 0. Any three kind of cases we can have in alternative hypothesis. But the point to be noted is there, in alternative hypothesis, if this is our case, then the hypothesis testing would be for the two-tailed testing, because we will be dividing our alpha according to our previous lecture on the both side of the normal distribution. Or if our alternative hypothesis is focusing on the one side of distribution, either it is on the positive side or it is mentioning on the negative side, that would be one-tailed distribution. That all is being explained to you in the classroom. That is actually that is in fact the first step where we state our hypothesis. The second step obviously is to select or choose the level of significance, and you know that the level of significance is being shown as alpha, and alpha, as I said, that traditionally we go for the 0.05 or 5%. Otherwise you can also take a minimum from 1% to maximum at 10%. But normally in the book and in these exercises we take 0.05 or 5% level of significance. In that case, this kind of formula I have given to you in Z distribution as well, but there the value of S, rather than we were using the population standard deviation, but here population standard deviation is not given to us, so here would be using the sample standard deviation S. If the population standard deviation was known, so there would have been used in this formula instead of this S. In fourth step, critical region, we define the critical region, and I told you that the we are using the T surface or T distribution. So all that alpha is the our critical region, which is more than plus T alpha divided by 2. You see that the alpha is not 0.05, it is 0.025, because alpha is being divided on the two sides of the distribution. So if 0.05 is being divided by 2, that becomes 0.025. So that 0.025 T distribution, if the T value is more than plus T alpha by 2 with n1 minus n minus 1 degree freedom, so this area would be called as a critical region. On the other side, on the left side, if it is found less than the minus T alpha with n minus 1 degree freedom, we will be finding this area. All these two shaded areas are called critical region. It is all already told in the classroom in detail. So we can write like this, and we can draw and write like this as well. So a shaded area, you know that this is explaining the minus T alpha over 2 with n minus 1 degree of freedom, and plus T alpha over 2 with n minus 1 degree of freedom. So this is our critical region. And the fifth step, we calculate our normal mean, and after that we get to the conclusion either our normal mean lies in critical region or lies in acceptance region, and then we can make conclusion accordingly. So guys, this test is similar to the as we have done in the Z distribution. You can do practice here as well, and for the practice questions I've mentioned on the page number 268. These are 5 or 6 questions, right? Almost 5 questions, 18.14 to 18.18, that is being shown here. So these 5 questions are there for the practice. I'll be doing just only one question for you, and after that rest of the 4 questions you have to do by yourself at home, and later on I'll be calling these questions as an assignment to be submitted on some date. I'll be explaining in the next announcement. So guys, I am just going for the first question, that is 18.14. If we see the question in larger picture, so that would be easily visible to us. 18.14 question is saying that a sample of 12 jar of the peanut butter was taken from a lot, each jar being labeled as 8 ounce net weight, 8 ounce net weight, and the individual weights in ounce are 8.2, 8.0, 7.8, 7.6, 7.7, 7.5, 7.3, 7.4, 7.5, 8, 7.4, 7.5. So actually each jar is being labeled that the jar is having the weight of 8 ounce, but when the 12 jar is being measured or calculated the weight, these different kind of weights have been drawn. Test whether these values are consistent with the population mean of 8, because the mean of 8 is given. Now look at this very carefully. The mean of population mean is given to us, so that's why here we will not put the value 0 into our null hypothesis. We will be putting the value of 8, and the rest, the sample of 12 is given to us, and we have calculated, we have measured the weights of these 12 jars. Now we will be testing whether these values, these jar sample values, either they are consistent with the population mean. So for that I'll be following T distribution. Why T distribution? Because we are not given the population variance, we are given the population mean. We are not given the population variance or standard deviation, and sample size is 12. So sample size is less than 30, and population variance or standard deviation is not given to us, so that's why we will be putting T distribution. So for that I would take help some other MS Office help. So this test, testing hypothesis about the mean of the normal distribution, population mean where the population standard deviation is not known, like are in question, and n number of observation is less than 30. So I'll be doing in this sheet, but we'll be taking help from Excel, because there are some values are given and we have to take the mean and the standard deviation of those values. So I have started I have opened this Excel sheet. I've just sorry, I will be having a simple smaller area, because values are not that much bigger. So that's why I'll be taking help from this Excel sheet while the question is there. The questions, we just minimize the question up to this section so that we can have the values. Now Here I am putting the weights of the jar of 12 jar, and these are the weights of the 12 jar, that is 8.2, sorry, first jar, and second is 8, then 7.6, then 7.6 again, then 7.7, then 7.5, 7.3, 7.4, 7.5 again, 8, 7.4, and 7.5. So these 12 jar are having a different kind of weights. Now we have just to calculate the mean and standard deviation, and for mean obviously I have to go for the formula of the average, and average is obviously showing all the selected area, and just I'm putting enter. So we have the mean of these 12 jar as 7.64. Now in the next column or next row I'll be having the standard deviation. So here we are going for the standard deviation of sample. So standard deviation is there, I think, standard deviation, STD, this is standard deviation of the sample. So it is asking me for the region. So this is our region of the selected values, and this is our standard deviation of these 12 jars. So guys, I have calculated the mean and the standard deviation. This is the mean, and this is the standard deviation. So mean and standard deviation is found out. Now we have just to follow the procedure, and for procedure the first step is telling us that setting the hypothesis, and we are given null hypothesis that if you see this, a sample of 12 jars of the peanut butter was taken from a lot, each jar being labeled 8 ounce per weight. So this 8 ounce can be taken as a population mean. So because the population mean is given, so that's why here I will not be putting the value of 0, I will be putting the value of 8. Either this population mean would be found exactly equal to 8, or I am taking two-tail testing if it is not found equal to 8. So therefore I am just erasing all other kind of alternative hypothesis. So here I have established hypothesis statement as a null hypothesis that the population jar is having mean weight as 8 ounce, otherwise it is not equal to 8. So this is our null hypothesis and alternate hypothesis. Obviously in the end one hypothesis among between of these would have been selected. Let's see what our results tell us. So next step is level of significance. We can check it on 0.05, 5%, we can check it on 0.01, we can check it on 0.10 or 10%. Normally we will be going for 5% test. Formula is this. Formula tells us that to find out the normal mean, we will subtract population mean by our sample mean, and rest of the values are given to us in this question. We will just okay with it, and we will just putting the value and get the answer. Critical region at 5% level of significance with n minus 1 degree of freedom. Here n is 12. So let's see what kind of value I can take, that is 12 minus 1 is equal to 11. So two-tail testing, we have to see the table of t distribution in the column of 0.205 and with the degree of freedom of n minus 1, that is 11. So for the table I'll be I'll be referring to you the same chapter, same PDF file, and in that PDF file you will find the t distribution table on the page number 244. So this is, guys, the table of t distribution, and this is 0.025, we were looking for it, and 0.025 we are looking on against the degree of freedom 11. So this is our degree of freedom, this is 0.025, and we get the value of 2.201. So guys, tabulated value we find out just as 2 point. Again I'm showing you, this is our number of degree of freedom, that is 11, 12 minus 1, and this is the column of 0.025. so this value, you can see that 2.201 is our critical value. So here I can put all these value, like minus 2.201, this is our negative side, and this is our positive side, 2.201. So this is our a critical region. If our estimated value found out to be more than this plus side or less than this negative side, then obviously we will be rejecting our H naught. So here we are going to calculate our value, and according to our calculation, our mean is 7.641. 7.641. So just I'm just taking help from this kind of tools. 7 point, this is 641, and divided by I'm just taking help from the tool. So sample standard deviation I have calculated as 0.2811, 0.2811, and number of observation, we know that our number of observation are 12. So guys, these are the value, and by having calculated this formula, we will be getting some kind of answer. Let's take help from the calculator. Calculator is there. So this is the calculator. I'm just having standard deviation. This is our square root of the 12. Anyway, we will be dividing 0.281 by this 3.464. 3.464. So 0.281 divided by 3.464. So that is 0.0811. 0.0811. Then I'll be dividing this 7.6 divided by 0.0811. So again I'm doing 7.641 divided by 0.0811. So that is equal to 94.21. Guys, I have to look at this whether I've done something right or wrong. I think we have done we have made some mistake. This is not 0.0811, it is 0.811. So I'm doing it again. This is 3.646 464. 0.281 divided by 3.464, 0.0811, and then I think we have made some mistake here. Here I'm having the formula that is x bar minus mu. So I have put the value of x bar, but we have not subtracted the value of mu, that is 8. So here I will be doing this again, and this is our calculator. So that is 7.641 minus 8, so that is 0.59. Clear? So that would be minus 0.59, sorry, minus 0.59, and then by having this value we see that what it comes to us. So that is see 12 having the square root of this is 3.464. so the 3.464. So, and after that, following this, I'm just doing it step by step just because of you, that some of you would not be able to calculate accordingly, so that's why I'm doing it just for you. So just now I am dividing this 0.281, sorry, 0.281 divided by 3.464, 0.0811, so that is 0.0811. Then finally we will be getting the value of t, normal value of the mean, so that would be 0.59 divided by 0.0811, that becomes 7.27. Okay guys, 7.27 is our value. 7.27 our calculated value. So we have calculated our normal mean of t distribution, that is 7.27, and our critical value was 2.201 on the left side and the right side both, and this value is in negative. So this negative 7.27 is far below than the minus 2.201. It lies in the critical region. So here now we are heading towards the conclusion side. So here we can see, or we can write that since our calculated value lies in critical region, that is minus 7.27 is less than minus 2.201. Therefore we reject null hypothesis that the population mean is ounce 8. So guys, this is we have drawn the conclusion. So in the step 6 we have concluded that the hypothesis what was established like that our population mean is equal to 8, that has been rejected. The population mean is found not equal to 8 through this process, and we have taken the sample of 12. Thus how we can get any kind of hypothesis testing for this special case. So this is one example. I'll be doing example next example, second question of the same case in the next video. Thank you guys. Thank you very much.